Yes, good morning, everyone. Now let us see jump statements or transfer of control from within loop. Transfer of control within looping are used to terminate the execution of loop, exiting a loop halfway through to skip the loop. These are the three situations where we need to transfer of control within the looping is required. So these all things can be achieved with the help of three important statements: break, exit, and continue statement. Break statement, in the sense, it has two uses. One use already we have seen in the switch statement, and another use is inside the loop. Whenever we are executing a set of statements, we want to stop the execution of a loop and we want to terminate the execution of a loop, or we want to transfer the control of execution from the loop to the statement which is written outside the loop. In such situation, we can use break statement. Break is a keyword also, and break must be used always with the if statement. Otherwise, your program will stop, your loop will stop in between on. Now see, here they have given so here there is a for loop. They have given n equal to 0, n less than 100, n plus plus, P out n. N value will be printed. But when the n is equal to 10, it should stop. Even though loop condition is up to 100, when the value of n becomes 10, it is going to stop. Right. Suppose assume that you are not giving this if statement, then what happens? As I said, break should be used always with the if statement. In this case, first it will print the value of n as 0. First it will initialize the value of n to 0. Then, as for loop is an entry controlled loop like while loop, so it will check the condition. Condition is evaluated to true because 0 is less than 100 is true. Then it will get inside the body of the loop and prints the value of n. N is 0. And after n, immediately break is there. Break means stop the execution of a loop and transfer the control of execution to the statement written outside this loop here. That means even though loop you have written 100 times, it has to be repeated 100 times, but because of break keyword, so it will, in the first iteration itself, it is going to come out from the loop. So suppose if I'm writing if n modulus 2 is equal to 0, that means when n is having a even number, that time it should stop. That means now in this range 0 to 100, it will print 0 and 1 because 2 is a even. So when 2, n value is 2, break keyword will execute and it will come out. Suppose if I say n modulus 2 is equal to 1, when n is odd, it is going to stop the execution of a loop, right? So like this, with the help of if condition, as per the requirement, right? So it should, the break keyword can be used. So here you can see at the right side in your textbook, they have given NI status to test whether a given number is prime or not using break statement they have given. The prime number is 1, where a number is divisible by itself and not itself and 1 and not divisible by any other number is a prime number. So here to check the prime number, what logic they are using is, suppose assume that the value x is a 11. I want to check whether it is prime or not. How we have to do? 11 you try dividing it from 2 and check whether the remainder is 0, but condition is false. 11 modulus 3 is equal to 0, you check, condition is false. Similarly, go on checking up to 11 minus 1, that is what? 11 modulus 10 is equal to 0. One way, this is also false. That means from the value, by leaving the number 1 and 11, from all other numbers, we are dividing this 11, right? From 2 to the given value 11 minus 1, that is up to 10, we are checking. So nowhere the remainder is 0. That means it can be decided that 11 is a prime number. So one more way is, instead of moving from 2 to given number minus 1, so what you can do is you can go up to the half of the given number. The given number is what? 11. Half of the given number is 11 by 2. So 11 by 2 means 5.5. As x is an integer or denominator is an integer, so it will be only 5. That means what? I have to try only up to 5. Now, it's not required to go up to 10. So here 11 modulus 3, 11 modulus 4 I'll try, and 5. Only up to 5 if I check it's enough. I'll come to know whether it is prime or not. So suppose somewhere if it is getting 0, for example, assume that 11 modulus, say I'm checking for 12. In such case, what happens now? 12 twos are right. Remainder is 0. Condition got true. You need not to go with these things. So at this stage only, you display the message that the given number is not prime. So this is the technique they are using here. So it is n I status, enter the value for n, and status is equal to 1. I variable is initialized to 2, that is denominator value, and see I is moving up to n by 2. Only half of the given number if you move, it's enough. If n modulus I equal to 0, status, it was 1, no, they are changing the value to 0 and see displaying the message as it's not a prime, and break. Break means, see the arrow mark clearly they have shown the control of transfer of execution will be shifted to the statement which is written outside the loop. This is the body of the loop. This is the range, right? If status, right? If status means what? If status is having a value 1, 1 means true, 0 means false. If status means if status is 1, it prints a message as prime number. Suppose if the status is set to 0 because this condition was true, then it will print this message and this message will not be printed. Now coming to exit, the break keyword just it will terminate the loop. It will not terminate the program. After terminating from the loop, it continues the execution from the statement written after the loop. It's clearly shown with the arrow mark. But what is this exit? So just you can, as you can break out of a loop, you can break out of a program also, right? There are some situations where on certain situations, I want to come out from the program itself, not from the loop. I'm saying I want to come out from the program itself. In such case, the C++ standard library function exit can be used, where it will terminate from the entire program itself. It will force the control of execution to come out from the program, right? So this is the exit, and this is the syntax of that prototype of that exit, right? How to use it? Check it out to test whether a given number is prime or not. So here in this case, what they're doing, same program is there. So if n modulus of I equal to 0, not a prime, and exit 0 means directly it will come out from the program. Suppose if n modulus I is not equal to 0 throughout the looping statement, then after completing all the repetitions from for loop, it will come to this line and it prints a message as it's a prime number, right? So like this it will do. See, suppose for example, if I say 12 value only if I take, right? 12 modulus 2 is equal to 0. It is true. So it prints a message. It is not a prime, and exit. Exit means what? Directly come out from the program itself. It won't execute These lines directly come out from the program. And then suppose if I'm taking 11 as a to check whether it's a prime, so entire loop until the executions or the iteration of the looping statement until it completes entirely, right? So this statement will not get true. When it will not get true, these two lines will not be executed. When these two lines are not executed, it will come to this line and it will print this message and close the program. Sample output you can see. There is one more statement called continue statement, right? So continue statement causes the program to skip the rest of the loop in the current iteration as if the end of the statement block had been reached, causing it to jump to the start of the following iteration. See, causing it to jump to the start of the following iteration. This point is important. The continue statement works somewhat like break statement instead of forcing termination. However, continue forces the next iteration of the loop to take place, skipping any code in between, right? So syntax of writing is continue. For example, here assume that I'm writing if n is equal to 10, right? Suppose if I write break, what happens, right? So here break in the sense what once when the n value is 10, it will come out, it will terminate the loop, means it will come out from the loop. That means after from 10, afterwards any other number in the loop will not be printed. That means from 0 to 9 numbers are printed. Suppose for example, instead of break, if I write continue, so what happens is when n is equal to 10, right? When n is equal to 10, continue means it will skip any other statements which are written below the continue statement inside the loop. Inside the loop, not outside the loop. Inside the loop, all those statements will be skipped and it continues with the next iteration, right? It will cause it to jump to the start of the next iteration by skipping the statements written below the continue keyword, but the loop execution will not stop. Loop execution continues to execute until the loop condition gets false. Suppose if I'm writing if n modulus 2 is equal to 0, that means when the even number is there, continue means only the odd numbers will be printed, right? Because whenever even numbers are there, we are telling a language to skip those number. That is why only odd numbers will be printed. Fine. This is continue keyword. So these three things you should know clearly. You should have a clear concept regarding this. If any doubt, update in the comments. So now here, see one example is there. N is equal to 10, n greater than 0, n minus minus. The loop is starting with the value 10 and it's moving up to 1 because they have said greater than 0. When n value becomes 0, it has to come out from the loop and n is being decremented every time by 1. If n is equal to 5, continue. That means what? Here, when n is 5, continue means what? This line inside the loop will not execute. That means n value will not be dead, right? But it will continue with the next repetition. The loop will be repeated entirely until condition is false. There is one more called as goto statement. Goto allows to make an absolute jump to another point in the program, right? The jump may be towards in the forward direction or it may be in the backward direction where the transfer of control can be shifted to from one point of the program to any other point of the program, right? So when you are using goto, remember goto is a single statement, single keyword, no space in between goto, and lowercase letter have to be used. And here goto, you have to write the label name, right? You have to write label name. There should be a space after goto. By mistake, here space is missed in the textbook. So label name has to be given, right? So here, when you are writing go to at the end, you have to give semicolon. You can see here they have given label name. That means when you say go to, the control of execution will be shifted to the location where label name is written. It may be in the after the go to statement or before the go to statement. Throughout the program, wherever you write this label name, no? So it will go to that point, right? That is go to statement. But using go to statement, if we write a programs, then it will be considered as an unstructured programming style. That is why it is it happens that we don't use go to even a one time also. But go to earlier we were using to repeat, to do the repetition. That is what we are doing now using looping statement. No, the same work we were doing it earlier by using this looping, by using this go to statement. One example I want to show you here. In this loop, it's going to print value from 1 to 10. So it is I. And here the same thing, if I want to write it by using go to, then how I can do it, right? So here I'll say, for example, int I is equal to 1. And I'll say cout and else IO manipulator header file should be included. Then I is printed. Then I plus plus, I'll say here, I'll say if I is less than or equal to 10, then I'll say go to X. X is my label. So X should come to this point. So until I less than or equal to 10, it will be moving from this location to this location. But once when I is more than 10, this statement will not execute. So it will continue from the remaining part of the thing. So like this, we were doing the handling repetitive operations. But now, instead of this, we have got while, do while, and for very advanced statements. So we are not using this go to. So it has become very rare that we use go to statement. All right. So here, this chapter ends. That is chapter 10 is completed. In the next class, we are going to start with chapter 11, arrays. Okay. Thank you. Bye, everyone. Have a nice day.